Hello everyone. The next electrophilic substitution reaction of phenol is again a name reaction, Reimer-Tiemann reaction. Very important for 12th, JEE, NEET and BSc. Let's check what that reaction is. Actually, the reaction can be performed in two ways. The first way I am explaining you. Phenol will be treated with chloroform and sodium hydroxide. Chloroform, colorless liquid. Sodium hydroxide we have to use in solid form as a white pellets, color of sodium hydroxide tablets. Phenol is very well known to us, crystalline solid, colorless crystalline solid it is. All the three chemicals will be mixed and will be heated up to 340 Kelvin temperature. The very first compound generated will be this. On benzene ring we will have a aldehyde group, and at the place of hydrogen we will have sodium. This compound is known as sodium salicyl aldehyde. It will be in the form of white powder. Now this white powder will be treated with dilute hydrochloric acid, means acidification you have to perform. After acidification, the sodium will be replaced by hydrogen, rest molecule as it is. Now out of aldehyde and OH, aldehyde will be the main functional group. The numbering will start from here. So OH is working as a side chain, we will call it hydroxy. So IUPAC naming will be 2-hydroxy. And this whole compound, benzene and aldehyde group, is known as benzaldehyde. Benzaldehyde, or you can call it ortho-hydroxy benzaldehyde. Because they are ortho to each other. And common name is salicyl aldehyde. Mostly it is called by its common name, salicylaldehyde. Colorless, oily liquid it is. Similarly, in this reaction, para-hydroxybenzaldehyde is also possible, this one. But this compound will be in minor amount. Very less para-hydroxybenzaldehyde will be generated, and it will be in major amount. There is a reason for it. This hydrogen is carrying partial positive charge, as you know why. This oxygen is carrying partial negative charge because it is more electronegative than carbon, so electrons are transferred toward this oxygen. Positive, negative, they have a force of attraction between each other, which we call intramolecular hydrogen bonding. And the process is also known as chelation, which is providing extra stability to this molecule, which is not here. OH and COH are far away from each other. That's why such intramolecular hydrogen bonding is not possible here. So this compound do not have that extra stability. That's why this ortho product will be major here. Now up to 12th level, how we can learn this reaction? Let's check. Very simple it is. This is our phenol, and as you know, this benzene ring have a high amount of electron density on ortho and para position due to resonance of this oxygen, which can be attacked by an electrophile. Who is electrophile here? Take a look. This carbon is connected with 3 highly electronegative chlorine atom. So this carbon obviously will have strong positive charge because the electrons are transferred toward chlorine like this. This is not an exact mechanism. This is a trick to understand this reaction without mechanism up to 12th level. Okay. Now simply what you need to do, because it's a positively charged carbon, as you know, positive particle want electron. So I'm going to attack it on ortho position. You can attack on para position also, but para attack will be minor, as I told you the reason. Ortho will be major, so I am attacking on ortho position. Okay. So as you know, carbon can make maximum 4 bonds. Already it is making 4 bonds. So if it has to make bond with this carbon, initially it have to break its older bond. Out of carbon Cl and carbon hydrogen, carbon Cl means carbon chlorine bond is weak. Why? Because it is a lengthy bond or big bond. And between carbon and hydrogen, bond length is short. Short bonds are strong bond and lengthy bonds are weak bond. So obviously carbon chlorine bond you will break. So any carbon chlorine bond you can break, like suppose I have broken this one and I am going to attach it on benzene. Just attach it on benzene. That's it. Don't worry about the bonding, what kind of bonding it is, or what will happen with this Cl. Don't worry. We are not doing mechanism. We are just finding a trick to learn this reaction. Okay. After this compound is generated. Let me write it again. This compound is generated. Now we are treating it with sodium hydroxide. The sodium hydroxide, you know, this is positive particle, this is negative particle. So NaCl, out of carbon and Cl, Cl have a negative charge, higher electronegativity. Similarly, this Cl, one more NaOH, positive, negative. Just do this one. Remove these NaCls and join OH at the place of them. Like this. NaCls will be removed out. 2 NaCl removed out. This one. On a same carbon, 2 OH group. I have already discussed many times with you. On a same carbon, 2 OH groups are highly unstable. So what will release out? H2O will be released out. Always this will happen. In previous videos, check. Whenever a same carbon have 2 OH group, always H2O will be released out. So that you have to do. And obviously how it will release out? Like this oxygen is breaking bond from carbon, electrons will transfer toward oxygen because oxygen is more electronegative than carbon. And if oxygen is breaking bond from hydrogen, so it will bring electrons toward itself. So if step by step you want to watch, you can check, this will happen. This oxygen will have extra electron and this carbon will have a vacant orbital. So they will make bond with each other to satisfy each one. Finally, we will get this one. Just make a double bond between carbon and oxygen. This one. Okay. So aldehyde group is joined there. Now, you know this hydrogen is also acidic, positively charged, and NaOH is a base. So one more NaOH can react with it. Positive, negative, OH negative, hydrogen positive, acid base reaction. H positive, OH negative, as a H2O they will released out. Between oxygen and hydrogen bond will break and at the place of hydrogen sodium will come. ONA and COH. Sodium salicylaldehyde will be generated like this. In this fashion you can learn this reaction up to sodium salicylaldehyde. Very easy. 2-3 times you will do it and it will be on your hand. Very easy. This is acidic hydrogen, this is base, just acid base reaction. H2O will be released out and Na will be joined at the place of hydrogen. So sodium salicylaldehyde will be generated. Now after sodium salicylaldehyde, how to make salicylaldehyde? It is a very easy reaction. This is negative, this is positive. We are treating it with dilute HCl. Now HCl, you know, always break in 2 parts, H positive, Cl negative. So just H positive will attack on oxygen negative and Cl negative will attack on sodium. So finally again, at the place of sodium, H will come and COH as it is, NaCl will be released out. salicylic will be generated. In this fashion, up to 12th level, easily we can learn this reaction. No cramming, easily we can understand that. Now let's go for the actual mechanism. Little bit changes are there, but most of the things are like this. Let's go for the mechanism part now. Now, step 1. The chloroform which you are using, this is the actual mechanism. Now check. This hydrogen is connected with this carbon, and this carbon is further connected with 3 chlorines. As you know, chlorine is highly electronegative atom. So obviously what they are doing, they are attracting electrons toward themselves. Due to which this chlorine have a partial negative charge, this chlorine have a partial negative charge, this chlorine have a partial negative charge, because they are attracting extra electron of carbon toward themselves. Due to which, due to loss of 3 electrons, this carbon will have partial 3 positive charge. It is the electrons of 3 electrons of this carbon are being attracted by these 3 chlorines. So it will have partial +3 charge. Due to this strong +3 charge, in turns, this carbon will attract electrons from hydrogen strongly. So this hydrogen will lose its electron very strongly. That's why this hydrogen will have high positive charge. That's why this hydrogen is working as acidic hydrogen. Now on this acidic hydrogen, who can attack? You are using base NaOH, Na positive, OH negative. You know NaOH will break always in this way. This one. This OH negative base and this hydrogen is acidic. That's it. This is the first attack. This acidic hydrogen of a chloroform is being attacked by OH negative coming from sodium hydroxide. Between hydrogen and carbon bond will break, and obviously electrons will completely transfer toward carbon, and this hydrogen will release out as H positive with a vacant orbital. Its vacant orbital will be satisfied by lone pair present on this oxygen. 3 lone pairs will be there. One is extra there. That's why this oxygen is carrying -1 charge. This lone pair, it will use to make dative bond with this hydrogen. So H2O will be released out. The positive charge of hydrogen will finish because 1 electron it will get, and the negative charge of oxygen will finish because 1 electron it has transferred toward hydrogen. 1 it will keep with itself. So this will be the water molecule which will be released out. Now here, this carbon will be in this condition now. Check. This pair of electron will be generated on it, and a negative charge will be there because out of these 2 electrons, 1 electron was of hydrogen. Now this carbon is carrying extra electron of hydrogen. So right now it is carrying -1 charge. What this molecule will do? Obviously -1 on carbon is highly unstable. So in this condition, 1 chlorine will break bond from carbon like this. And obviously chlorine is more electronegative than carbon, so electrons will transfer toward chlorine. Next condition generated will be this. Lone pair on carbon as it is. Here vacant orbital will generate because these 2 electrons are gone with chlorine. Now chlorine is carrying extra electron of carbon. This electron was of carbon, so it will become -1. And please by yourself put 3 lone pairs on every chlorine. You know when chlorine is making single bond, always 3 pair of electrons are there. So if I am not drawing, draw them by yourself. Okay, vacant orbital is generated, 1 chlorine, 2nd chlorine as it is, no change. Now there will be no charge on carbon. Why? Because it was carrying extra electron of hydrogen, that's why -1 charge was there. At the same time, chlorine has broken bond from it and it carried 1 electron of carbon. So 1 electron was gained, 1 electron is lost. So overall there will be no charge on carbon. Such type of carbon which is generated here, it's an intermediate, we call it carbene. And if I talk about the complete name, we call it dichlorocarbene. This is carbene intermediate. Like carbocations are there, carbonyls are there, nitrines are there, carbon free radicals are there. One more intermediate is there which we call carbene. What are carbene? Look, we know carbon have 4 unpaired electrons around it. If out of 4, 2 it has used to make bond with any atom or group and 2 unpaired electrons are unused, such carbene is known as carbene. Now, carbene are also of two types. If these 2 unpaired electrons are in different orbitals, we call such carbene triplet carbene. Triplet carbene. And if both unpaired electrons are in same orbital, we call it singlet carbene. Singlet carbene. The hybridization of singlet carbene is sp2, which it is. In this Reimer-Tiemann reaction, the carbene which is generated, it's a singlet carbene. Singlet carbene, because both electrons are in a same orbital, and hybridization of this carbon will be sp2. So this is the first step. Now please check, this carbene have vacant orbital, means it have a tendency to gain electron. That's why this carbon is also working as electrophile. It is working as electrophile. It wants electron. Who can provide electrons to it? Yes, phenol, benzene ring. So what will happen in the next step? This electrophile is going to attack on a benzene ring of the phenol for the electrons. Let's attack. But before that, in a first step, one more small point. Please add it in a first step. You know, in phenol, this hydrogen is also acidic. It is acidic because it is connected with oxygen, and oxygen have very high electronegativity, due to which electrons are transferred toward this oxygen. That's why hydrogen is losing control on its electron. So it have a very high positive charge. So it can also be attacked by a base. We know NaOH we are using. So obviously OH negative, Na positive, OH negative is going to attack on it. Between hydrogen and oxygen, bond will break. Both electrons will transfer toward oxygen because oxygen is more electronegative. So phenol will also turns Na positive will attack on it. Between sodium and O negative, we will have ionic bond. Ionic bond. And what will release out? H2O will release out. OH negative, H positive will make bond, ionic bond will generate between oxygen and sodium. So what it is? Sodium phenoxide. Sodium phenoxide means in first step, phenol will turns to sodium phenoxide and chloroform will turns to dichlorocarbene as an intermediate. Now this sodium phenoxide and dichlorocarbene are going to combine with each other in second step. Let's start. Second step of the mechanism. This is sodium phenoxide, and we know that due to resonance on ortho and para position, electrons are available. But I am not going to attack on para position, I will attack on ortho position. Reason we know. With its vacant orbital is making this carbon electrophile, and also it also have a positive charge because it is connected with chlorine and they are attracting electrons, so partial positive charge is also there. So it's working as an electrophile. With its vacant orbital, it will attack on ortho carbon here. For bond formation, we require 2 electrons. Right now, here we don't have any electron. This is a vacant orbital. So the responsibility of providing electron will be of this carbon. How it will provide? Many a time we have done this resonance, this mechanism. Shiftage of pi electron will be there. And these pi electrons will be utilized to make bond with this carbon, and bond will be dative. So let's make it lone pair as it is, 2 chlorine as it is, and it has made dative bond with it. Weight, charge. Now look, it was 0 charged. There is no charge on it right now. When this electron will completely transfer toward this carbon here. Means it got extra electron. This electron is extra for this carbon. So overall charge will become -1 here. This is the important point. Rest molecule as it is, no change. QPO, oxygen and sodium as it is. This carbon has lost its electron, so vacant orbital on it, positive charge. Here we have hydrogen, rest molecule as it is, no change. Arenium ion, carbocation is generated here. Is it stable? No. How it will become stable? Many a time I told you, this carbon who has made it carbocation will help it. How it will help it? It will sacrifice its hydrogen. It will break bond from its hydrogen and will shift its electrons here. Vacant orbital, pair of electron will come, double bond will be generated here. And what about this hydrogen? It will release out as H positive without any electron. So first let's make double bond here. Double bond here, rest molecule as it is. I will not change right now anything. Step by step we will understand. No change. H positive is released out, this one. Okay, now what this H positive will do? Here it have option. This carbon with a lone pair carrying a -1 charge means it is unstable. This hydrogen have a vacant orbital with a positive charge means it is also unstable. If they can make bond with each other, they can satisfy each other. Both instability will be finished. That they will do. Between this carbon and this hydrogen, dative bond will be generated. Let's make it. So we will get this compound, this one. Between hydrogen and carbon, dative bond will generate. Positive charge of hydrogen will finish and the negative charge of carbon will finish, because out of those two electrons, one electron it will transfer completely toward hydrogen. So its negative charge will finish. One electron it is getting, hydrogen is getting this one, so its positive charge will finish. This is generated here. Now, next step, you know what will happen. Third step. Let's make a third step here. In the third step, these ClCl will be substituted by OH groups. These two chlorines have a negative charge. They have a negative charge on them. Why? Because chlorines are more electronegative than carbon, so electrons are transferred toward chlorine side. That's why they are carrying negative charge. And you know the medium is basic. Here we have NaOH, Na positive, OH negative, Na positive, OH negative. They are very well known to us. So simply Na positive will attack on Cl like this. And when Na positive is going to attack on Cl, Cl will break bond from carbon, and obviously both electrons will transfer toward chlorine, because chlorines are more electronegative than carbon. So don't you think carbon will have a vacant orbitals on it? Those vacant orbitals will be satisfied by the lone pair of oxygen. At the same time, oxygens will attack on carbon, because carbon will have a vacant orbitals. After breakage with Cl, vacant orbital, breakage with Cl, vacant orbitals, positive charge will come. Due to that positive charge, negative particles means OH negatives are going to attack on it. And between carbon and oxygen, dative bond will generate, because here we will have a vacant orbital, here we have an extra lone pair, vacant orbital, dative bond. So we will get this compound. Between oxygen and carbon, dative bond will be there. Now two lone pairs I am going to draw them, because the third lone pair they will use to make dative bond with carbon, like this one. And side products will be 2 NaCl, this one. That's it. Now we know what will happen finally. Finally we know between when carbon have two OH group on them, unstable, steric hindrance, how they will release out? OH will break bond from carbon, and here oxygen will break bond from hydrogen, and both electrons will come toward oxygen. Means from here H positive will release out with a vacant orbital, and from here again OH negative will release out. Between them, lone pair vacant orbital, bond will generate, H2O will release out, water molecule. And here when oxygen will break bond from carbon, vacant orbital, let's write it here. Here I am writing, please check. The molecule will turns to this one as it is. Vacant orbital, so positive charge, and oxygen with 3 lone pairs with a negative charge. This type of particle will generate there. Vacant orbital, lone pair, they can satisfy like this. Vacant orbital, lone pair, double bond will generate, and let's write it here. H as it is. Between carbon and oxygen, double bond will generate this one, COH group, aldehydic group, and 3 pairs, 2 pairs will left because 1 pair it will use to make bond with carbon. That's it. What is generated? Sodium salicylaldehyde. Sodium salicylaldehyde. So this is the third step, and after this generation of sodium salicylaldehyde, you know what will happen? We have to treat this molecule with dilute HCl. Acid will provide us H positive, Cl negative. That's it. H positive with a vacant orbital. It have a vacant orbital. Vacant orbital will attack on oxygen for lone pair. Between oxygen and hydrogen, bond will generate. Na positive will be released out. Between oxygen and hydrogen, dative bond will be there, so positive charge of hydrogen will finish because it has got 1 electron completely toward itself, and oxygen's negative charge will finish because 1 electron it has transferred toward hydrogen. Out of 2 electron, 1 electron it will keep with itself, so both will be neutralized. COH group as it is. The compound generated is known as salicylaldehyde. And here Na positive, Cl negative will combine with each other. NaCl will be generated as a side product. That's it. This is the end of the mechanism of a first type of Reimer-Tiemann reaction. Now in next video, next type of Reimer-Tiemann reaction, only little changes there, rest part as it is. Thank you very much for watching the video.